Hello, so I have here isopropyl alcohol and I've been filling up this flask with isopropyl alcohol. Now, by the way, I'm going to say right at the top, I don't recommend using a flask this size for a number of reasons, but this is what I have and we're not exactly a high budget production company here. So we're going to do a nice little experiment. I'm actually going to use the isopropyl alcohol from the inside. You'll see why in a minute. So by the way, point the stick down because alcohol flows down, but when you light it, point the stick up because fire goes up. And now we're gonna light. All right, well, this time I'm gonna use this. Okay, I'm gonna get a little more in there and we're gonna light it, and here it goes. So I'm gonna now light the fuel in the beaker. Well, it lit, didn't it? But it did stay lit, did it? So that's strange. How many scientific discoveries start with that strange? Let's try it again. Well, what's going on? This makes a wonderful little inquiry you can do with your students. Like, well, what's going on? Why is it not lighting? Is it burning? I hear a little bit. You always want to listen. Now, the beaker's getting warm, so that should be a clue. You did see some flame, but why did it go out? Why does the flame keep going out every time it goes in? Up, I take it out, it starts on fire again. I put it back in, goes out. Why is that happening? Wonderful inquiry to do with your students. Have your students try to figure it out. Now, by the way, something I need to tell you, before you do this, make sure you remember basic safety. Eye protection is required for everybody, no exceptions. Also, remove any flammable materials from the workspace. No papers, anything like that. You want to use a regular school desk. Don't try this at home. School desks, certainly in America, are made of highly fire retardant materials. They don't burn well at all. I can't say that if you got a nice lacquered table at home. You probably don't want to do this there. Also, do a dry run. I've never had one of these things break on me, but there's a first time for anything. So make sure if you're going to do this when there's no kids around first, in case something goes wrong. I've never had one break. First time for anything, though. All right, now let's keep going here. So the students will eventually figure out that probably the problem isn't about fuel. It's about oxygen. Lots of fuel, but the air doesn't have enough oxygen. Air is only about 1/5 oxygen, and remember, liquid is far more dense than air. Most of the molecules in the flask are down there at the bottom in the form of liquids. Far fewer molecules up here. As a result, you run out of oxygen molecules long before you run out of fuel molecules. And that's why we still have plenty of fuel, but it just simply isn't burning. Well, you got a little air. But you notice that I pull it out, it's on fire, put it back in, it goes out. Again, with a smaller beaker, smaller opening, the air won't keep getting in as quickly. So you won't have that flare up every single time. You know, once it's out, it'll probably stay out if you use a smaller flask than this one. By the way, don't use a 4-inch flask. You don't want something that might roll over. Now, okay, the students have come to the conclusion that the problem is a lack of oxygen. How do you test this theory? Well, lots of fuel in here, not a lot of oxygen. Out here, lots of oxygen, not a lot of fuel. Now, this is, by the way, one of those other reasons why you want to do a dry run, because this next part, one of the things you need to think about is not just about the flammability of your work surface and of your desk, but is there a fire alarm you might set off? You know, are you in a lab building? In a lab building, the fire alarm should be fairly tolerant because people expect to have Bunsen burners and stuff like that. In a regular classroom, you might want to be a lot more careful, have the windows open because you don't want to set off the fire alarm. By the way, also, use this alcohol sparingly. I just put a little bit on the desk, and the reason why is when you light it up to see if the oxygen's the issue, yes, you can see the oxygen's making a big difference, but that's a very, very small amount of alcohol I put there. You want to be very careful not to put too much. Again, this is where a dry run's important. You can figure out how much to put down that will be safe, but yet make a good demonstration. Dry runs are very, very important. Also, make sure you have proper fire equipment. Know where your fire extinguisher is. check to make sure your fire extinguisher has not expired. Every science lab should have a huge bag of baking soda. It's not just good for fire, it's also good for chemical burns. Also, and this is really, 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 really important, I'm using isopropyl alcohol. Don't try this with other fuels. Don't try this with gasoline for certain. You want something that doesn't expand too explosively, because you don't want to shatter these borosilicate glass. By the way, make sure it is borosilicate. I don't know if anybody makes a flask that isn't borosilicate, or also known as Pyrex, but just be safe. Also, the thing about isopropyl alcohol is it doesn't burn super hot. For example, I can take this, put it on my finger. Oops, I got it down my hand. Oh well, and you can see my hand's on fire, but I'm burning my hair, but not much else. I got it all over my hand. Isopropyl alcohol doesn't have a very high flame temperature, which means that, get this off my hand. I'm gonna do this the way I wanted to do it. A little leaked around my finger, but yeah, it doesn't burn too hot. That's a big factor, because you're gonna notice that this thing's gonna get hot in the center, but not at the bottom. It's uneven heating. Borosilicate glass can take a lot of that, but there are limits. You don't want to use something that might burn too hot and cause the glass to crack. And if you see any sign of cracking, stop the experiment immediately, okay? So practice it several times before you actually try it with students around, and remember to follow these very basic safety advices. Make sure everybody's got eye protection, make sure you got fire extinguishers, baking soda, make sure that your desk is not gonna catch fire. Do dry runs. The more dry runs you do, the less likely you are to do something that's dangerous. But it's a fun inquiry experiment for kids. So I hope you've enjoyed this, and I hope you have a nice day. Remember, safety first. Bye-bye.